Hello, class. Welcome to Unit 5 review. This is part 2. So to continue on where we left off, question number 9. I have a national caterer determined that 87% of the people who sampled the food said it was delicious. A random sample of 144 people is obtained from a population of 5,000. The 144 people are asked to sample the caterer's food. If P hat is the sample proportion saying that the food is delicious, what is the mean of the sampling distribution of P hat? So before we actually go through the process of finding that value, we should probably do a check. Well, checks in this case. N times P times 1 minus P. 144 times 0.87 times 1 minus 0.87, which would be 0.13. This would give us about 16.3 as a result, which will then tell us that, this is approximately normal. We can also check that the sample size should be 5%, less than 5% of the population size. So 5% of 5,000, that's 250. And our sample size of 144 is indeed less than that. So the mean, the sampling distribution of the sample proportion will be 0.87. For question number 10. Excuse me. There we go. Question number 10. According to a study conducted in one city, 21% of adults in the city have credit card debts of more than $2,000. A simple random sample of 100 adults is obtained from the city. We want to describe the sampling distribution of P hat, the sample proportion of adults who have credit card debts of more than $2,000, rounding to 3 decimal places as necessary. So this would be 100 times 0.21 times 1 minus 0.21, so 0.79. This will give us about 16.6. And let's face it, that's greater than 10. So because of that, this is going to be approximately normal. So the mean of the sampling distribution of P hat will just be 0.21. The standard deviation of the sampling distribution of P hat will be the square root of 0.21 times 1 minus 0.21, so 0.79, divided by 100. This is about 0.041. Number 11, we want to describe the sampling distribution of P hat, assuming that the size of the population is 15,000, sample size is 300, and probability of success is 0.1. So for the normality, this would be 300 times 0.1 times 1 minus 0.1, or 0.9. This is 27. So the shape is approximately normal. We could also find 5% of 15,000. That number is 750, which of course is greater than 300. So this is going to be independent. The mean of the sampling distribution of the sample proportion will be 0.1, and the standard deviation of the sampling proportion of P hat 0.1 times 0.9 divided by 100. This will be divided by 300. this would be about 0.017. Question number 12. This is where we suppose a simple random sample of size 1,000 is obtained from a population whose size is 1,500,000 and whose population proportion with the specified characteristic is 0.49. We want to first describe the sampling distribution of p hat. So for this, we are going to do 1,000 times 0.49 times 1 minus 0.49, 0.51. This is about 249.9. So the shape is going to be the approximately normal. We can also do 5% of the population size. So 5% of 1,500,000. This is about 75,000. So 1,000 is definitely less than that. So our sample would be independent in this case. The mean of the sampling distribution of the sample proportion will be 0.49. The standard deviation of the sampling distribution of the sample proportion will be the square root of 0.49 times 0.51 divided by 1,000. And that is about 0.019. Part B wants the probability of obtaining 520 or more individuals with the characteristic. So p hat 520 divided by 1,000. This will give us 0.52. And the probability that p hat is greater than 0.52. So that's about this drawing. 0.49 is here in the middle. 0.52 would be down here. We want this area above it. So to toss this into StatCrunch for us, let me open this back up. So as we did before, this is stat, calculators, normal. The mean was 0.49. Standard deviation was 0.019. And the probability above 0.52. That's about 0.057 in this case. So 0.057. Part C here. Wants the probability of obtaining 470 or fewer with the characteristic. So p hat 470 out of 1,000. That's 0.47. And we want the probability p hat is less than 0.47. So 0.49 will be here. 0.47 will be someplace down here. And we want the area below it. So let me reopen up StatCrunch. And we need to change this to below. And this to be a 0.47. And we would get about 0.146 in this case. So about 0.146 in this case. And then carrying on from that, we have question number 13. Exit polling is a popular technique used to determine the outcome of an election prior to the results being tallied. We want to suppose a referendum to increase funding for education is on the ballot in a large town, voting population over 100,000 people. An exit poll of 500 voters finds that 245 voted for the referendum. How likely are the results of your sample if the population proportion of voters in the town in favor of the referendum is 0.51? Based on your results, comment on the dangers of using exit polling to call elections. So let's see. We can first do 500 times 0.51 times 1 minus 0.51 or 0.49. This gives us 124.95. So the shape here is going to be approximately normal. We could check the 5% of 100,000. That is about 5,000. So 500 sample size here is fine. The mean of the sampling distribution of the sample proportion will be 0.51. The standard deviation of the sampling distribution of the sample proportion, square root of 0.51 times 0.49 divided by 500. And that is about 0.022. So we are trying to calculate here the probability that p hat is less than 0.49. Why is it less than? Well, let's see. 0.51 will be here. 0.49 based on this standard deviation will be someplace down here. So for how likely are the results, if we do the area above it, that's going to give us a high probability. But if we do the area below, there's a chance it could be unusual for this particular problem. So to enter this then into step crunch for us, let me pull that up. So let's see. This is going to be a mean of 0.51, standard deviation of 0.022, and the probability below 0.49. And we get about 0.1817 for this case, 0.1817. And that's greater than 5% by a lot. So this result is not unusual. And then question number 14. We have here a researcher studying public opinion of proposed Social Security changes obtains a simple random sample of 50 adult Americans and asks them whether or not they support the proposed changes. To say that the distribution of the sample proportion of adults who respond yes is approximately normal, how many more adult Americans does the researcher need to sample in the following cases? 15% of all adult Americans support the changes. So sample size would be greater than or equal to, this would be the number 10 divided by 15%, so 0.15, times 1 minus 0.15, so 0.85. This gives us about 79. So since they already had a sample size of 50, this would be 79 minus 50. So they would need 29 more people. And for 20%, that changes this a bit. Sample size needs to be greater than or equal to 10, divided by 0.2, times 1 minus 0.2, or 0.8. This gives us about 63. And 63 minus 50 again means we would need 13 more people. So this is the end of part 2 of our unit 5 review. Let me know if you have any questions or concerns. Thank you.